Hello, 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 and welcome back. In this video, we're working through an example problem. In this one, we need to determine a vector that's perpendicular to a plane. And how is that plane defined? Well, it's the plane that contains the points 1, 1, 1, negative 2, 1, 3, and 4, 2, 5. So our first step in a problem like this is to plot these points, and that way we can visualize the plane, and that might give us some ideas of how we're going to find a vector perpendicular to the plane. Now keep in mind, remember the cross product of two vectors is always perpendicular to both of those vectors. That's going to be our key here. So instead of plotting these by hand, I'm going to use GeoGebra, which is an online three-dimensional calculator. You can do it in 2 dimensions too. You can do geometry with it. It's a pretty cool program. It's free to use. It's just called GeoGebra, and in particular, I'm using GeoGebra. I'm going to use GeoGebra 3D. So this is a resource that you can absolutely use because this is totally free. It's a good way to just kind of visualize some of the things we'll be doing in the class. So this is maybe the first point that we're really going to be exploring GeoGebra. So I'm going to jump into GeoGebra and plot those points. So I'll show you how to plot the points, and then we'll work through this problem with the aid of this tool. So here I'll jump over to GeoGebra. Now I've already plotted these points. They're up here. You notice that I define them P, Q, and R. This is exactly what I typed in to get this. I just said P equals parentheses 1, 1, 1, and I did the same for Q and the same for R. These were the points that were given. And then it plots them in the coordinate axis. So this red axis is my X axis, the green is my Y, and the blue is my Z, as I've laid out here. So I've laid it out just like we would draw these coordinate axes, maybe something like this or something like this. And it plots those points here in 3 dimensions so we can see all of them. Isn't that cool? And it can kind of explore just those 3 points. So any 3 points in space define a plane, and we're sort of working through that idea here. So the next thing I want to do is I want to make a plane that contains those 3 points. So I can do that in GeoGebra by just typing plane and then my 3 points, P, Q, R. And that generates a plane that contains those 3 points. As you notice, there's no other parameter here. That defined the plane entirely, and there it is. So all I want to get out of this problem, all I'm looking for here, is a vector that is perpendicular to this plane. That's what I want. So think about how I can do that, and remember that the cross product, if I take the cross product of 2 vectors, I get something that's perpendicular to both vectors. So pause again. If you want to think about this for a minute or two, do it. Pause the video here, think about how you might do this, how you might problem solve this, knowing what the cross product does and knowing this plane. One thing to think about is, where do I get those 2 vectors, and how do I know that a vector perpendicular to those 2 vectors will be perpendicular to my plane? So pause here if you want. All right, so how we can solve a problem like this is we need to get a hold of 2 vectors that are both parallel to the plane and not parallel to each other. I don't want 2 vectors that are parallel to each other, because then the cross product will just give me the 0 vector, and that doesn't help at all. So I want 2 vectors that aren't parallel to each other, but that are both parallel to this plane. So what I can do is I can make 2 vectors out of these points. So I can say take vector PQ and vector QR, and that'll be 2 vectors that are both in this plane, and then I'll take the cross product of them. So here's a way to generate vectors once you already have points, right? One way to generate a vector is to give the tail and the head of it in terms of points. So I'll say here vector, I want vector PQ will be that vector, and you can see it's plotted it for me. That's great. Notice it's parallel to the plane. And I could do vector, I don't know, RP or RQ or QR. Either of those will work. I'm going to say here vector, I'm going to do QR. Vector QR. And that makes that vector there. So notice this is the same, this is different notation for what we use is we put the Q and the R right next to each other and draw a arrow over it, right? That's this vector. And those are both parallel to the plane, and they're not parallel to each other. And so I know that when I compute the cross product, it's going to be perpendicular to both of those, and hence perpendicular to the plane. Let's see, I haven't done this in a while. How do I do cross product? Cross of two vectors. So I'm going to do vector. Notice it already named my vector PQU and my vector QRV. So what happens if I just say cross UV? Find the cross product of U and V. It makes a vector that is perpendicular to the plane. How cool is that? Notice if I did, let's say V cross U, I'd be going in the other direction. That's fine. I don't care which one, if you do U cross V or V cross U, or if you maybe found different vectors between these. As long as you have two vectors that aren't parallel generated from these 3 points, the cross product will give one that's perpendicular to the plane. So our next step is to actually find these vectors PQ and QR and then compute their cross product. That's our next steps. Here we go. I'll go back to my whiteboard and let's do this. So I want to take PQ. Let's find PQ first, and I want to find QR. So PQ, -2 minus 1, this is going to be 3. 1 minus 1, that's 0. 3 minus 1 is 2. QR, 4 minus -2, that's 6. 2 minus 1 is 1. 5 minus 3 is 2. All right, there's my vectors PQ and QR. Let's compute the cross product of them. I'm going to call this U, and I'm going to call this V, just so I know. So now I'm computing U cross V. And this should be perpendicular to the plane, as we saw with GeoGebra. So this is the determinant of a 3x3 matrix. Remember, you put I, J, and K across the first row, U across the second, -3, 0, 2. 6, 1, 2, like that. And then we compute the determinant. So this is I times the determinant of 0, 2, 1, 2. Remember what's left over is these 2x2. Minus J times the determinant of -3, 2, 6, 2. And then K plus K times the determinant of -3, 0, 6, 1. Cool. Let's compute the determinants of those 2x2s. 0 times 2 is 0, minus 2, so that's a minus 2i. -3 times 2, that's -6, minus 12. -6 minus 12, that's a -18, but j is negative, so that's a plus 18. You remember in GeoGebra how that vector was huge? It's coming from this term, the 18j. Okay, so -3 times 1, that's -3, minus 0, so that's minus 3. Okay, and so this is the vector, -2, 18, minus 3. And so here we have now a vector that is perpendicular to the plane containing these 3 points. Let's just check our math real quick. I'm going to go back to GeoGebra and just verify that that cross product really does look like this, minus 2i, 18j, minus 3k. So it should be pointing back 2, down 3, and to the right 18, if I have it set up that way. So let's see. I'm just going to jump back to this real quick. Yeah, look, so the green is our y-axis, so minus 18, or 18j, so look how much it's pointing to the left. Or rather, if we have it like this, like we normally do, it's pointing 18, so there's our 18j. It is pointing a little bit back, right? If I have it like this, it's pointing a little bit back. That's that -2i, and then it's going a little bit down, minus 3k. And there we have it. There's a vector that's perpendicular to the plane. It's pretty cool. And that is it for this video. We're going to work another example type problem like this that can be solved by using a cross product, but it's not initially obvious how to do so. All right, I'll see you there.